The Label Lens domestic wine pre-check pipeline has reached a critical milestone. The system successfully accepts an image input and utilizes a local Tesseract OCR engine to extract and evaluate label evidence. The scale of this implementation is substantial. Pull requests 37, 41, and 42 have been merged into the main branch, encompassing 128 changed files and over 16,000 lines of new code. Based on the internal metrics, the builder claims the system is ready for production scaling. The codebase currently reports 618 passing tests and enforces a rigorously locked fixture corpus contract. Despite that flawless test suite, a formal architectural audit, designated Rubber Duck Review 002, has evaluated the system and issued a hard mandate to pause and expand. The audit directly contrasts the builder's verified test coverage against unresolved questions regarding the pipeline's operational reality. The metrics prove internal consistency, but they lack the external validation required for deployment. This exposes a tension in software governance. Evaluating exactly how a highly tested, technically sound prototype can still be entirely unready to serve as a measurement baseline. High unit test counts and strict schema boundaries guarantee that modules function in isolation. Without independent, real-world evidence feeding into those modules, those identical metrics create an illusion of system readiness. The foundational design pattern of the system relies on RDR 0002. This directive requires a strict separation between probabilistic AI evidence extraction and deterministic regulatory conclusions. A label image enters the local OCR engine for probabilistic processing. It feeds into an analyzer schema, which only emits evidence states like observed or ambiguous, never regulatory conclusions. Downstream deterministic rules then evaluate this evidence to generate concrete findings, isolated from human workflows. By enforcing this rigid sequence, the architecture actively prevents probabilistic AI outputs from impersonating human authority or fabricating a regulatory pass. This epistemological wall successfully contains AI hallucinations. However, a strict schema boundary remains dependent on the modules sharing an exact, agreed-upon vocabulary across every layer. Round 1 of the audit bypasses the 618 passing tests by exposing a critical cross-layer defect in that shared vocabulary. The target is the pipeline's conservative brand name selector. It defends against adversarial attacks by aggressively excluding unclassified strings from being labeled as authoritative brands. An unclassified string, like Napa Valley, enters the Select Brand Observation function block. The selector assigns it an ambiguous tag and passes it forward with an empty alternates array. It immediately hits a schema validation barrier, which rejects the empty array, requiring alternate candidates. The outcome is a hard stop. The function attempts to validate the bad input, immediately returns an invalid response, and destroys what should have been usable system uncertainty. The engineering question is direct. How did a pipeline with over 600 passing tests allow a systemic failure in its primary data flow? The tests were comprehensive but isolated. The selector tests pre-validated their output before asserting success, while the schema tests asserted their rules entirely separately from the selector's actual output. Adjacent, thoroughly tested modules will compile seamlessly into a systemic failure if their shared vocabulary is not verified through integration. Without composition tests, system uncertainty breaks the pipeline. The builder attempts to lock the system's evaluation contract in PR42 by creating version 1 of the label fixture corpus. This stacked chart breaks down the actual contents of the 14-entry evaluation index, exposing a severe imbalance in the testing material. 11 of the entries highlight gray. These are purely synthetic cases constructed to test known semantic attacks. These synthetic cases bypass actual image pre-processing and the OCR engine entirely. They inject token lines directly into the downstream field selectors. Of the remaining 3 entries, one is an unavailable dataset gap in red, and one is a disabled low-resolution derivative in yellow. Only a single sliver remains green, representing the one enabled real OCR fixture. The reviewer's critique targets issue number 15, the project's measurement baseline. Executing a measurement baseline against this index will yield precise numbers, but weak external meaning. Advancing to a measurement baseline with one real label and 11 constructed inputs means the system only measures agreement with its own post-OCR assumptions. It proves absolutely nothing about real-world accuracy. The audit synthesizes these findings into a clear engineering directive. The isolated architecture of the system is technically sound, but the sequential project planning is flawed. This graph shows the circular trap in the remaining work plan. Issues 39 and 40 treat extraction, policy, and activation as indivisible gates, creating a closed loop that halts progress. The reviewer requires a linear correction: define evidence, normalize, then activate rules. The final closing checkpoint verdict from RDR 002 mandates a hard pause on any further feature expansion until independent, real-world evidence is acquired. Additionally, the single candidate composition defect must be hardened and resolved before any aggregate thresholds are permitted in the pipeline. Treating an isolated architecture as ready based entirely on internal consistency tests represents a failure in engineering governance. Real independent evidence must precede rule activation to validate the system.